Most people think when it comes to plumbing design in a building that everything is cookie cutter and you can just put equipment wherever you want and everything will work just fine from a maintenance and usability standpoint. On most projects, that's definitely not the case. I'm Matt Morgan with AWB Engineers. I'm a principal engineer with the company specializing in plumbing design. So let me walk you through some of the utilities for this facility. It all starts with incoming water. Water comes into this building, into a water treatment room. Water comes through this water booster system and is boosted up, and then goes through a water softener system to pull out iron, calcium that may be in the water. We've got a hot water system, which is a Ludel direct contact system. It allows to provide large quantities of hot water, and during peak production time, it allows them to have additional hot water on demand as they need it. So the second room in the utility building is the steam boiler room. 300 horsepower steam boiler providing steam for the facility. One thing to also point out is in this room, there's careful planning that has to be put in place for treatment of the boiler water as well as drainage. There's a trench drain that is in place, and the trench drain has to be located in the exact position based on the manufacturer in order to allow discharge to go into the system and meet manufacturer's recommendations. So the third room in the utility building is the air compressor room. Essentially, the air compressor will sit here on this pad. This room is quite large, and you'll see a single air compressor. This room has been designed to allow one air compressor to be installed now and future air compressors here and here in the future to allow additional capacity. The air compressor piping that goes over to the main building on the pipe bridge is sized to handle all three air compressors, so the owner doesn't have to install multiple runs of piping, thus saving costs from the get-go. We've got a pipe bridge that's been installed to allow all the utilities to be run over to the main plant and still allow truck traffic between the utility building and the main building, and provide an owner a spot for where they can access the piping and service it on that pipe bridge. So let's go take a look at the pipe bridge outside. Okay, so now we're up on the pipe bridge. There is a structure in place that allows all of the utilities from the utility building to come over into the main building. As you can see, there are roller supports at each one of these that allow you to adjust up and down piping that has to slope and also expand and contract due to temperature. So all of that has to be taken into account with the elevation of the installation of the piping as it gets inside the facility. Let's go inside the facility. Now we're into the interstitial space with all of the piping that's come in from the pipe bridge into the main area of the building. As you can see, there's not a lot of space. So in order to install all of this piping and give the owner access in the future to this piping and allow them to continue past the piping into the remaining area of the interstitial space for access, careful planning has to be put into place for slope piping and level piping as it was installed on the pipe bridge. All of this piping is in an exact spot, which allows you to also minimize the amount of area that you're taking up for the piping installation. In order to do this, we use a capability of 3D modeling all of the piping with required slopes and level piping. By modeling the piping early on in the design, it allows us to establish exact heights of installation of piping, thus saving a lot of time on the contractor's side when they install it. In the grand scheme of things, plumbing engineering is not cookie cutter. There has to be careful planning up front in order to have a design that meets the owner's expectations as well as allowing for serviceability in the future.